Hello, class. So we have made it to the end of chapter 1. All right, we are actually skipping section 1.9 and we are moving on to section 1.10, right? And we're talking about lines, okay? So, in standard form, okay, which this is how most questions will be given to you. In standard form, a line looks like this, okay? Ax plus by plus c equals 0. Okay, and this is pretty useless. All right, this is just what it looks like. All right, the more useful form, or the form that we want to be in, is called slope-intercept form. Okay, and this one is y equals mx plus b. And that should hopefully have, sounded very familiar. B, M is the slope. B is the y-intercept, okay? And so this is why it's called slope-intercept form, because when it's in this form, you can just see the slope and the y-intercept, okay? Now, a big deal, if you notice I put quotes here, is that the y-intercept is a point, all right? I want to make this a huge deal because this is like the number one mistake is that the y-intercept is a point. It's 0 comma b, okay? It's not just b. So slope, okay, what is slope? So slope has many words, okay? It's m. It's also rise over run, which is y2 minus y1 over x2 minus x1. And you can switch the order. So y1 minus y2, x1 minus x2, it does not matter. Okay, but this is slope, and so you need to be able to like figure it out, okay, given 2 points. Okay, so a common question you could get, a simple one, is just find the slope. Okay, so find the slope between points. P is 1, 7, Q is -2, 3. Okay, so to find the slope, m equal to, I'm gonna just call this x2, y2, x1, y1. So 3 minus 7, -2 minus 1. This gets you -4, -3. The negatives cancel. The slope is 4/3, okay? So not hard. Okay, you just plug them in, get the numbers, not too bad. Okay. The next thing you need to know how to do is graph. Okay, and so technically you know how to graph because there was a section where we graphed some things. But now we're gonna graph a little bit more carefully, or better, without having to plug in some points, okay? So I want you to be able to graph lines. Okay, so here's a line as an example. The first step would be, right now it's in standard form. We would want it to be in slope-intercept form. So I'm going to solve for y. Okay. So I'm going to move the 6x and the 2 over. Okay. Then I'm going to divide everything by 2. 1. And so here we are. Now it's in slope-intercept form. So I can see that the slope is -3 and the y-intercept is 1. So with those 2 pieces of info, I can graph. Okay, so here is the y-intercept, right? The point 0, 1. And I have slope -3. So what does that mean? So hopefully you actually have graph paper or something. Okay, so what that means is slope -3, you can think about it as -3 divided by 1. So this is the rise, and this is the run. So for every 1 that I move over, okay, I am going to go down 3. So rise -3, which kind of just means fall 3, and then run 1. And ta-da! So let me get one more here. Rise -3, run 1, and then we can connect. Okay? And so this is how you should be graphing lines, okay? Is you find the y-intercept or find a point and then slope, okay? And rise over run. So run, rise, okay? Down 3 over 1, down 3 over 1, okay? All right, so let's graph another line, okay? So example 2. Graph 3y minus 4x plus 9 equals 0. Okay, so same thing. Right now it's in standard form, so let me get it into slope-intercept form. So I'm going to move these two over. Then I'm going to divide by 3 and get this thing. So we can see slope y-intercept. Okay, so I get the graph. Okay, so the y-intercept is -3. So 1, 2, 3. And then I'm gonna need 1, 2. Let's see how this goes. It's a little steep. Okay, so y-intercept -3, that's there. Okay, and I'm going to rise 4, run 3. So go up 1, 2, 3, 4, and then go over 3. And ta-da! Okay. And hopefully it works. If I go 1, 2, 3, 4, and go over 1. That's okay. Let's ignore that part. Ta-da! Okay, it's a line. Okay, so not too bad. All right, now, moving on a little bit, I'm going to introduce a third form. And this one is kind of optional to learn. Most math professors encourage learning this form, just to make your life a little easier. But this one is called point slope form. All right, and it looks like y minus y1 equals m x minus x1. Okay. So this is called point slope form for a reason. One, because we see that the slope is here. But instead of b, the y-intercept, we have this thing. Okay? We have a point, x1, y1. All right, so this is useful because it helps you answer questions fast. All right, so for example, if we had the question, write an equation for the line with slope 3 over 2 and goes through point 1, 5. Okay. We have two options to do this. Okay, option one is we use point slope form. So option one is use point slope form. So we have y minus y1, so this is 5, m parentheses x minus x1, which is 1. And ta-da, you're done. Okay, so this is why point slope form is nice, is because you are instantly done. The only time this is not allowed is if the question specifically tells you write the equation in slope-intercept form. Okay, which for online homework, it almost always did force you to do that. So you'd have to, like, you know, do some algebra right now. You'd have to distribute the fraction. So 3 over 2, and then add the 5 over 3 over 2x, and then plus 5, so that'd be plus 7 over 2. Okay, so a little more work if you're forced to put it in slope-intercept form. But if you're not, then, you know, it's pretty nice. Over. Okay, option 2. So if you don't want to use slope-intercept form, point slope form, you can use slope-intercept form, but you kind of have to fill in the blanks. Okay, so y equals m, so we know that, x plus b. So right, our goal is to find b, right? How we do that is we can actually plug in the point 1, 5. So we can plug in 5 for y and 1 for x. And then now we have a linear equation that we know how to solve, right? Subtract 3 over 2 from both sides. 5 minus 3 over 2 equals b. 10 over 2 minus 3 over 2 equals b. B equals 7 over 2. Ta-da, and look, see, they match. Okay. So 2 options. 1, point slope form. 2, slope intercept form, but you got to plug in and find b. Okay. Pick your favorite. All right, does not matter. But that's how we can use a slope and a point to make a line. Okay. Now, a slightly longer version of this question is write the equation of the line that goes through points 1, 2, -3, -4. Okay, so here it's just kind of a longer version of the question because they didn't give you slope. So you have to figure that out first. Okay, so m equals, and so this is why we talked about what the slope formula is. -4 minus 2, -3 minus 1, -6, -4, those cancel, 3 over 2. Okay, so the slope is 3 over 2, and now we have slope and we have points, so we can use point slope form. So y minus 2 equals 3 over 2 x minus 1. And now, so some of you might be asking, why did I pick this point? The truth is, it does not matter. Actually, y plus 4 equals 3 over 2 x plus 3. Both of these are actually correct, okay? Because if you solve for y, so let me put these into slope-intercept form. 3 over 2 minus 3 over 2 plus 2. y equals 3 over 2x plus 9 over 2 minus 4. Y equals 3 over 2x. What is that? That is 1/2. Is that 1/2? That is 1/2. Y equals 3 over 2x. 4 is 8. So right, instead of 4, I'm going to do 8 over 2. And then you get 1/2. And look, they're actually the same. So this is why both of these are okay. Okay, is because they're actually the same line. All right, it does not matter which point you pick. You can just pick one. All right. And ta-da. Okay, so good. So that's pretty much the forms. Okay, so we have 3, right? We have standard form, slope intercept form, and then this point slope form if you want to choose to use it, which I like it. Okay, now I'm going to kind of talk about some special cases. Okay, and that is vertical and horizontal lines. Okay, so vertical and horizontal lines. So first of all, vertical is up, down, horizontal side to side. Okay, so I know a lot of you guys might be confused, right? Here it is, vertical up, down, horizontal side to side. All right. So horizontal lines look like this, y equals b. Okay, and if you look at that, then it's just the slope equals 0. Okay, so let me just graph a couple. Okay, y equals 1. So here it is at 1, and it's flat. Okay, y equals -2. Here it is, and it's flat. Okay, nothing groundbreaking here. These are horizontal lines, slope 0. Y-intercept this number. Okay. Vertical lines, all right, are a little bit different. They are x equals a. Okay. And so if we graph them, right, they'll look like this. So x equals 2, 1, 2, and you get a vertical line. Okay. X equals -3. Oh, let's go -1. Ta-da. X equals 0 is technically the y-axis also. Fun fact. Okay. So these are vertical lines, and if you kind of look at them though, right, you might be wondering what's the slope, right? The slope is rise over run, and this rises like all the way, but doesn't run. So in fact, the slope of vertical lines does not exist, okay, or it's undefined. We don't talk about slope when it comes to vertical lines, okay? All right. So another thing is that vertical lines and horizontal lines are perpendicular, okay? So I just introduced a new word. Okay, so this is the last part of the section and possibly the most important part, because guaranteed this will show up in the future. Perpendicular lines. All right, you need to be able to know when lines are parallel and perpendicular and how to make them, okay? So parallel and perpendicular lines. The short story, okay, the fast way is lines are parallel, okay, if they have the same slope. Okay, so same slope, parallel. Perpendicular, okay, if it's the opposite, okay, reciprocal. Okay, so we say lines are perpendicular if their slopes are opposite reciprocals. So m1 equals -1 over m2. Okay. And here it's m1 equals m2. All right. So let's do some examples. Okay. So first thing is just simple questions like, are the lines 2y equals 5x minus 2 and 3y equals 6x plus 5 parallel, perpendicular, or neither. Okay. And this really not that hard, right? You're just testing if they are. So what you do is you need to find both of these lines' slopes. So I'm gonna call this one L1 and L2. So line 1 has slope 5 over 2, right? If I divide both sides by 2, we can see this is the slope. Okay. Line 2 has slope 6 over 3, which is 2. Okay. So we can see that they're not parallel because they're not the same. And they're not perpendicular because they're not opposite reciprocals. Okay. Now, if we play with this formula, this one, okay, you can also tell if lines are perpendicular if when you multiply the two slopes together, you get -1. Okay, so here's a good example of this. Y equals 3 over 4x plus 2. 2y equals 3, just kidding. Actually, no, never mind. -4 over 3 x plus 1. Okay. These lines are obviously perpendicular, but just to prove this concept, okay, if I take m1, 3 over 4, and multiply it by m2, -4 over 3, right, everything cancels and you get -1. So these lines are perpendicular. Okay. All right. Now the next set of questions are a little more complicated than just are these lines parallel or perpendicular? Okay. The next set of examples are you going to be finding a line. Okay, so find an equation of the line through the point 5, 2 that is parallel to the line 4x plus 6y plus 5 equals 0. Okay? So here you have to make a line, right? This is different. So if we go through this, we can pick out the important parts. Parallel, this point, and this line. Okay? So step 1 is this line. We need to figure out its slope. So I'm going to figure out this line's slope. Y equals 4 over 6x plus something. So the slope is 2 over 3. Okay. So if that's m1, Then M2, we have to first check, do we want a parallel line or a perpendicular line? Here we want parallel. So that means our M2 is going to be the same thing. Okay, 2/3. And then we have a slope and a point. So point slope form. Oh, just kidding. X minus 5. Okay, and then this is the answer. If you wanted to put it, you can put it in y-intercept form also. Okay. So this is the other kind of question you'll get, is to make a line. Okay. So next example. So now I'm going to do a perpendicular example. So perpendicular to 6x minus 5y equals 3 at point 1/2, 0. All right, so again, step one, right? Step one, we want to figure out this line's slope. Okay, so I'm going to solve for y. So 5y equals 6x minus 3. So the slope is 6 divided by 5. Okay. Then, step 2, I want to check what I want. Do I want parallel or perpendicular? Here I want perpendicular. So that means my second slope is going to be negative 5/6. Okay, so we flip the sign and we then also flip the fraction. Then step 3, this depends on your choosing, but you make the line or put it in slope-intercept form. So, or point-slope form. So y minus y, so okay, actually, so minus 0 equals negative 5/6 x minus 1/2. And actually, this is already in slope-intercept form if you just distribute. So let's distribute. We're going to get positive 5/12. Ta-da! Okay, so this line is perpendicular to this line at this point. Okay, so yeah, perpendicular, parallel. Okay, lastly, just let's do one more example. Just just so you can get 2 in of perpendicular lines, because those are, those require just a little more work. Okay, so perpendicular to 3y plus 4x equals 2 at point. Okay, let me actually make this a 1. Okay, at the point 1, -1. Okay, so again, the first thing I'm going to do is I need to figure out this thing's slope. So m is going to be equal to 4/3. Okay, then I want to figure out my new line slope, and again, I'm doing perpendicular, so that means my new slope is going to be negative 3/4. All right, and then lastly, I have a point and I have a slope, so I put it into point slope form. Negative 3/2 x minus 1, and ta-da, we're done. Okay, I'm gonna put it in slope-intercept form just in case, just to do it. So this will be plus 3/2 minus 1 which equals -3/2 plus, right, this is 2/2. So 1/2. So ta-da! Here is the line perpendicular to this line at this point. Okay. All right. And then just to wrap up the section, this is really like not important. Okay. But horizontal lines, okay. So horizontal lines are perpendicular to vertical lines. And then vertical lines are parallel to each other. And so are horizontal lines, are parallel to each other. Okay. These I hope are obvious, right? If you just like graph them a little bit, right? I hope you can see how it's clear. The only reason we have to say these specially is because remember, vertical lines don't have slope, and we kind of used slope to define what these are, okay? But it should make sense. And then parallel lines never intersect, okay? So parallel lines never cross, right? That's probably also the definition you guys learned if you learned this, forever ago, okay? But that wraps up section 1.10 and chapter 1, right? So see you guys next class in chapter 2.